All right, we are going to do, I got a lot of emails today, all actually regarding the same several questions, so I'm going to do all of those here. We're going to start with number 2. And for number 2, they're asking to, you have the measure of two supplementary angles, and the ratio is 3 to 5. What is the length of the largest? Well, whenever we have this instance, well, first of all, we got to know supplementary means 180. So if we don't know that word, you're going to be in some trouble. So we know that 3x plus 5x, because I'm just applying the ratio, is equal to 180. Okay, so that's all my equation is. I'm going to combine my like terms. I get 8x is equal to 180. Divide both sides by 8, and x comes out to be 22.5. Now, that's not the answer. That's just the value of x. Okay, one angle is 3x, one angle is 5x. They're asking me for the largest angle, so that's got to be the 5x. So now I just need to simply take 5 times my 225, and when I do that, I think I get 112.5. So that is the length of the largest angle there. Okay? Keep moving on. I had questions for both A and B for number 3, so we'll take a look at A first. The directions are saying to determine if the figures are similar. If they are, write the similarity statement and give the scale factor. If not, explain why. Well, if to be similar, you need to know that all the sides that correspond are proportional, or give you the same scale factor, or really produce the same fraction. And you need to know that all the corresponding angles are congruent. So, this one's pretty easy. You could just take this figure and like literally slide it over, right? D would fall here, C and G, B and E, A and D. Okay, so if you were to do that in your brain, all the angles that match up would all be congruent. And then every single scale factor is going to give you a scale factor of 4 to 6. Now, I tell you to reduce that, and you divide it by 2, you get 2/3. The scale factor is 2/3, or if you work this way, it would be 3 to 2. But nonetheless, it's all the same. So for letter A, yeah, they're similar. Figure A, B, D, C is similar to figure D, E, F, G. Okay, and the scale factor was 2/3. Now, B is a slightly more tricky. I'm going to just rewrite or redraw, because I would flip this in my brain and draw it this way, knowing that this would be Q, my right angle here would be P, and this would be R. Okay, PR is 15, PQ is 8, this is 17. So now that it's laying the same way, now I think we would agree Q and K correspond, they're congruent. P and J, they're both right angles. R and L are both congruent also. So all the corresponding angles are the same, which is step 1. Now I need to check all of the sides, make sure they give me the same scale factor. I'm going to compare small to big. Okay, so as I compare PQ and KJ, I get 8 over 16, which gives me a half. If I do PR to JL, I get 15 to 30, which is also a half. And then if I do QR to KL, I get 17 to 34, which is also a half. So, are these figures similar? I'm going to erase this so I have a little bit more room. The answer to the question is yes. So we can say, I'm going to erase this too so I have room to write all this. The answer is yes. Triangle KJL is similar to triangle QPR. Okay, and the scale factor was always 1/2, or if you did the other way, 2 to 1. Okay, so there's your answer for 3A and B. The next one I'm going to do, I was asked, a couple people asked about letter 4B. To do this, you want to, first of all, I'm telling you in the directions that these figures are in fact similar. Okay, so the only thing that I do know for certain is 9 and 6, and they compare to each other, and I'm going to always use 9 to 6, and then I'm going to compare everything else. Okay, so if I wanted to find, z, for example, so I'm going to compare 9 to 6. Now, because I'm comparing 9 to 6, well, then I have to compare z to, I'm sorry, that's not the right side, to the z corresponds to 3.5. So I compared 9 went on top. That means z has to go on top to 3.5. Okay? When I do this, I cross multiply. 6z is equal to 31 and a half. Divide both sides by 6. And z is, I think, 5 1/4. So there's z. Okay? So I'm going to erase this and give myself more room to do this. So I'm going to keep using 9 to 6. And if I wanted to find then y compares to 6. So I cross multiply. 54 is equal to 6y. 9 is equal to y. Okay? And then lastly, you would do the same thing for x. So 9 compares to 6 as 12 is to x. Okay, so that would give you 9x equals 72. Cross multiply and divide, and you get x to be 8. Okay, so there's your answer for B. All right, and we have number 5. Okay, we take a look at these. They're asking you to determine if the triangles are similar. So if you recall, we had 3 ways to prove triangles are similar. You have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Side-side-side and side-angle-side required the sides to be proportional or produce the same scale factor, and then the angles had to be congruent. Okay, so those are our tools in our toolbox to figure this out. So if we take a look at A, okay, the 2 triangles, this one is in blue, and this one we'll put in red. Both the blue and the red triangles both share angle S. So we know that angle S is congruent to angle S. Okay? So if that's congruent to itself, I need to check to see if the sides are proportional. Well, the first thing I need to understand, or I need to know, is how long RS is. Well, RS' whole length is 36. So 36 is the whole length of RS, and I'm going to compare to that 24, because that's the part of the blue triangle. Okay? When I do that, I believe that will reduce down to, divide them both by 6 would give you 4, so 2/3. Okay, so the scale factor here is 2/3. Now I need to see if this side's scale factor is also 2/3. Well, if you had 16 and 8, you get 24, and compare that to 16. And when I simplify that, that will also give me 2/3. So both this side and this side both have a scale factor of 2/3, and angle S is congruent to itself. Therefore, triangle PSQ is similar to triangle RST by side-angle-side similarity. Okay? So that is your work for, was that 5A? This one requires a little bit less work, but you need to really know your rules here. So we have a pair of parallel lines, and that's going to play a big role here. Whenever you have parallel lines, let this act as your transversal. Find your N or your Z. That tells me that these 2 angles are congruent. Okay. You could also say that, well, let this be your transversal. And you could say these 2 angles are congruent. Finding your N or Z there. And then also you have vertical angles here in the middle. Now you only needed 2 pairs of corresponding angles to be congruent, and we have obviously 3. So therefore, I can make the conclusion that triangle triangle GFH is similar to triangle JKH. Alright? So, from here, we know they are similar by angle similarity. Alright? Last one. This was a big hitter on section 7.4. And I was only asked to do B. Now I will tell you, if you're stuck on A, you know, the whole thing here is said to be 50. It tells you that piece is 10. That's a little hint for you there if you're having any issues there. In letter B rather, I would find Y first, and I would do my part of the hypotenuse as the altitude is to the part of the hypotenuse. So 3 is to Y, as Y is to 9. When I do my cross multiplication, I get 27 is equal to Y squared. And if I square root both sides, 27 is not a perfect square. The biggest perfect square that divides evenly into 27 is 9, and the square root of 9 is 3. So Y is 3 radical 3. Alright, and then lastly here for X, so this is the second formula then you would need to use, which is the part of the hypotenuse, let's try this again. The whole hypotenuse is to the leg, as the leg is to the part of the hypotenuse that's physically closest to that leg. Okay, so the whole hypotenuse is 12, compares to the leg. The leg was X. And again, remember, everything is predicated or comes back to your one big large triangle. That's what everything comes back to. Okay, so again, the whole hypotenuse, which is now 12 because 9 plus 3 gives you 12, is to the leg X, as the leg is to the part of the hypotenuse. So it's split in half. This is a part, and that's a part. 9 is the part that is closest to that leg. Okay, so when I do my cross multiplication, I get 108 is equal to X squared, and this is not a perfect square either, so when I take the square root of 108, the biggest perfect square that divides evenly into it I think is 36, and you get 3 in return. The square root of 36 is 6, 3 stays underneath the radical, and that is your answer there. If there are any other questions, please make sure to email me at snydere@nhsd.net. Thanks, guys. Enjoy your evening.